Welcome to our YouTube channel of series of basic process engineering calculations. In this session, we will see how to calculate the air leak rate throughout the system. As a engineer, there are the air leakage, so there results in the vacuum drop in the system. So I will explain step by step how to calculate the air leak rate. Basically, it's allowable air leakage rate while designing any of the vacuum system, that may be a vacuum pump or that may be a ejector system. The vendor considered its in between range of 2 to 4 kg per hour of air leakage rate. So if that's much amount of air leakage is across the system, that means that system gives the required vacuum. And if the vacuum is not getting, that means there are possibility of leakage, air leakage on higher size throughout the system. So I'll to calculate that, I just consider one example. So we first need system volume. So that includes the volume of the reactors, then the piping, condenser, and the its catchpot, or the you can call it the receiver. Okay, so that system volume considers all the system whichever is connected to the vacuum system. Okay, so we need initial vacuum, so that's then the final vacuum, as we are checking for the leakage. Okay, so I'll just mention the notations. Then P1 is the initial vacuum, delta P. Okay, that is the vacuum drop that requires to check. Okay, vacuum drop in of Hg. Okay, so to perform this leak rate checking test, we need the total hold up time. Hold of time for air leak rate check. Okay, so that is the T. Okay, these are required to calculate. Then we need to convert that vacuum drop in from M of Hg to M bar. Okay, so then we will get the air leakage rate. Okay, in kg per hour, we can give it as MA. Okay, so for these calculations, I'll just take one of the example here so that you will get the idea. So I have approx 4 kL reactors, its piping and its receiver, all accessories that includes the system volume we considered as the 6 kL. Then we have initial vacuum of 643.5 mmHg. Then the final vacuum is the 710.5 mm of Hg. Okay, so we have to check the delta, how much vacuum is dropped. Okay, so it's the vacuum drop mmHg. Then we have to perform that test. Someone considers for the half hour, someone considers for the 1 hour, so I'll just consider for the 1 hour test. Okay, so once we have done that, we need to convert that vacuum. So we will need to convert that vacuum into the M bar gauge. So I'll just simply convert 3334. So that's the m bar. Okay, so now we have the all the inputs values which requires to calculate the air leakage rate. As I'll just uh, add this formula here, so you will get the idea about which formula and what is the relation we are using to the calculation of air leakage rate. Okay, so air leakage rate, here I simply drop down the calculation values whatever we required here. So we will calculate that simply here. 0.071 into the vacuum drop delta P into the system volume divided by the time whatever we have considered for these calculations or the performing that test. It's 0.33%. Okay, 33 air leakage rate. So it's the air leakage in kg per hour. So we just simply needs the rated capacity of vacuum pump. Okay, so rated capacity we need to take as per the our requirement, or what is the installed actual nm per hour. So we assume that key 30% efficiency, okay, of the 30% efficiency of the vacuum pump at highest vacuum. Okay, so just needs to multiply that by 30%, so that's the 78 nm cube per hour flow rate of the vacuum pump. So we need to convert that air leakage rate in nm cube per hour. Okay, as we have vacuum pump capacity and all these details in the nm cube per hour, so I just simply to convert that into nm cube, simply divided by 122, so we'll get that nm cube per hour. Okay, so hope you got the clarity about the deal calculation. Now we calculate the air leakage in percentage, how much percent of air leakage is happening across the system. So air leakage in percent, we'll just simply needs to divide that by 78. So we'll get into 100 as we are going to calculate. This is the in percentage. Hope you got the idea about how to calculate the uh, air leakage rate in terms of a vacuum drop in case throughout the system. So based on that, sometimes you need to calculate the what would be the effective oxygen concentration, effective O2 concentration in case of air leakage concentration, because these are the points you will get during the risk assessment phase. So you need to calculate the air leakage okay rate, and based on that need to provide whether that system is uh, safe in terms of oxygen uh, percentage available throughout the system, which avoids the flammable zone. Okay, so you can simply put that So you will get the how much percentage of the oxygen content in case of air leakage. That much percentage of the O2 will remain in the system in case of air leakage happens during the process. So hope you got the clarity about how to calculate the air leakage rate in the system. Still, if you have any doubts, you can drop me a message in the comment section. I'll get back to you. Thank you for now.